At the end of the topic, you will be able to determine the coordinates of points using section formula, calculate the ratio in which a point divides the line segment.
Coordinate system has been used since ancient times for navigation, archaeology, and even space exploration. But today, the coordinate system has been modified and used for different purposes. For example, archaeological grids are used to comb a site for artifacts. The polar coordinates help to track aircrafts. On the other hand, planetocentric coordinates are used by NASA to map Mars' surface and atmosphere. Computer coordinates are used as a grid of tiny dots that make up animations and graphics.
Let us look at the division of a line segment. A line segment can be divided in two ways, namely, internally and externally in the ratio m:n. P divides the line segment AB internally in the ratio m:n. This implies AP by BP is equal to m by n. P divides the line segment AB externally in the ratio m:n. This implies AP by BP is equal to m by n. Let us look at the section formula. If P divides the line segment internally in the ratio m:n, then the coordinate of P is mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n. If P divides the line segment externally in the ratio m:n, then the coordinate of P is mx2 minus nx1 by m minus n, my2 minus ny1 by m minus n. If P divides the line segment in the ratio 1:1, then the coordinate of P is x1 plus x2 by 2, y1 plus y2 by 2. This is known as midpoint formula. Example 1. Find the coordinates of the point P which divides the line joining the points 1, A 7, 2 and B 1, 1 in the ratio 4:3 internally, 2, A 3, 4 and B minus 6, 2 in the ratio 3:2 externally. Click on the solution button to view the solution. Example 2. Find in what ratio the point P divides the line joining the 2 points A and B if P, A and B are the points -1, -1, 4, 4 and 7, 7 respectively. Click on the solution button to view the solution. Example 3. Find the coordinates of the midpoint of the line joining the given points -8, 6 and 12, -2. Click on the solution button to view the solution. Centroid of a triangle. Centroid is the point of intersection of medians of a triangle. If G is the centroid of a triangle ABC having vertices A x1 y1, B x2 y2 and C x3 y3, then the coordinates of G are given by x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Example 4. Find the centroid of the triangle whose vertices are 4, 2, 1, 4 and 3, 2. Click on the solution button to view the solution.
Using the section formula, show that the points A 1, 0, B 5, 3, C 2, 7 and D -2, 4 are the vertices of a parallelogram taken in order. Click the solution button to view the solution.
In this topic you have learnt the coordinates of the point P, xy, which divides the line segment joining the points A, x1, y1 and B, x2, y2 internally in the ratio m:n is mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n. The coordinates of the point P xy, which divides the line segment joining the points A x1 y1 and B x2 y2, externally in the ratio m:/n is mx2 minus nx1 by m minus n, my2 minus ny1 by m minus n. The midpoint of the line segment joining the points x1 y1 and x2 y2 is x1 plus x2 by 2, y1 plus y2 by 2. The centroid of the triangle formed by the points x1 y1, x2 y2 and x3 y3 is x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3.
At the end of the topic, you will be able to deduce the formula to find the area of a triangle, calculate the area of a triangle, determine the condition for collinearity. Let us find the area of a triangle using a shortcut method. Let ABC be any triangle whose vertices are A, x1, y1, B, x2, y2, and C, x3, y3. Arrange the vertices as shown. Therefore, area of the triangle is equal to half into x1, y2 minus x2, y1 plus x2, y3 minus x3, y2 plus x3, y1 minus x1, y3. Let us discuss the condition for collinearity. Let ABC be any triangle whose vertices are A, x1, y1, B, x2, y2, and C, x3, y3. Area of the triangle ABC is equal to half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. If the points A, B, C lie on a straight line, then they are collinear, which implies area is equal to 0. Delta is equal to half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 is equal to 0. Learn this method to calculate the area of a quadrilateral. Consider a quadrilateral with vertices A, x1, y1, B, x2, y2, C, x3, y3, and D, x4, y4. Arrange the vertices as shown below. Then the area of the quadrilateral is equal to half into x1 into y2 minus y4 plus x2 into y3 minus y1 plus x3 into y4 minus y2 plus x4 into y1 minus y3. Example 1. Find the area of the triangle whose vertices are 4, 5, 1, 3, 0, minus 4. Click on the solution button to view the solution. Example 1. Find the area of the triangle whose vertices are 4, 5, 1, 3, 0, minus 4. Click on the solution button to view the solution. Example 2. Show that the points 12, 5, 6, 2 and 2, 0 are collinear. Click on the solution button to view the solution. Example 3. Find the area of the quadrilateral with vertices 6, 9,
7, 4, 4, 2 and 3, 7. Click on the Solution button to view the solution. In this topic you have learnt area of the triangle formed by the vertices x1, y1, x2, y2 and x3, y3 is half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Three given points are said to be collinear if the area of the triangle is 0. Area of the quadrilateral with vertices x1, y1, x2, y2, x3, y3 and x4, y4 is half into x1 into y2 minus y4 plus x2 into y3 minus y1 plus x3 into y4 minus y2 plus x4 into y1 minus y3.
At the end of this topic, you will be able to compute the slope of a straight line under various conditions. When the standard equation of a straight line is given, when the angle of inclination of the line is given, when the coordinates of 2 points on the line are given, test the parallelism and perpendicularity of 2 lines.
Let us learn about the inclination of a line. The angle between a line and the positive direction of the x-axis is called the inclination of the line. This angle is always between 0 degrees and 180 degrees and is measured anticlockwise from the positive direction of the x-axis. Inclination is an important factor while building roads, skating boards, or even making toy trains.
Slope of a line. Let us define the slope of a line. The slope of a line is a number that measures its steepness. The slope of inclined plane is a ratio of vertical height and horizontal distance. That is, slope is equal to vertical height divided by horizontal distance. Note that slope is also known as gradient.
Slope of a line, given the standard equation of a straight line. For every m an element of R, the slope of the line y is equal to mx plus c is m. Y is equal to mx is a line with slope m and passes through the origin.
Consider a right-angled triangle ABC in which angle BAC is equal to theta. Here, tan theta is equal to BC divided by AB, which is equal to vertical height divided by horizontal distance, which implies slope m is equal to tan theta. If the inclination of the line is theta, then tangent of theta is called the slope of the line.
Slope of a line, given the coordinates of 2 points on the line. Given a line, the ratio of the difference between the two y coordinates to the difference between the two x coordinates of any 2 points on the line gives the slope of the line. If x1, y1, x2, y2 or any 2 points on a line L, the ratio y2 minus y1 by x2 minus x1 is called the slope of the line. Click on the derivation button to learn about the derivation. Let us see what happens when slope of lines parallel to axis. The equation of the line parallel to the x-axis is of the form y is equal to a, where a is any real number. If a line is parallel to the x-axis, then its y-coordinate is the same for all the points on the line. Therefore, m is equal to y2 minus y1 by x2 minus x1 is equal to 0 by x2 minus x1 is equal to 0, since y1 is equal to y2. Therefore, the slope of a line parallel to the x-axis is 0. The equation of the line parallel to the y-axis is of the form x is equal to a, where a is any real number. Therefore, m is equal to y2 minus y1 by x2 minus x1 is equal to y2 minus y1 by 0 is equal to infinity, since x1 is equal to x2. Slope of a line parallel to y-axis is not defined. Parallel lines. Slope. Any two parallel lines have the same slope. Y is equal to mx plus c1. Y is equal to mx plus c2. Represent two parallel lines with slope m. Conversely, two lines are parallel if and only if their slopes are equal. Consider y is equal to m1x plus c1. Y is equal to m2x plus c2. Then m1 is equal to m2 if the two lines are parallel. Equation of two parallel lines can be made to differ in the constant term only, coefficients of x and y being the same.
The condition for perpendicularity is as follows. Look at this image provided here. Let L1 and L2 be two perpendicular lines, making angles theta 1 and theta 2 with the x-axis. Then, M1 is equal to tan theta 1 and M2 is equal to tan theta 2. Since the exterior angle of a triangle is equal to the sum of the interior opposite angles, we have theta 2 is equal to theta 1 plus 90 degrees. Taking the tangent on both sides and simplifying, we get m1 m2 is equal to minus 1. Therefore, two lines of slopes m1 and m2 are perpendicular if m1 m2 is equal to minus 1, and conversely, if m1 m2 is equal to minus 1, the lines with slopes m1 and m2 are perpendicular.
Let us look at an example. Find the slope of a line joining the points 1, 3 and 4, 6. Click on the solution button to view the solution. Let us have a look at an example. The line joining A minus 2, 4 and B 3 minus 5 is parallel to the line joining C 0, 4 and D minus 3y. Find y. Click on the solution button to view the solution.
Here is the next example. Show that the points 4, 3, 2, 1 and 7, 6 are collinear. Click on the solution button to view the solution.
In this topic, you have learnt to compute the slope of a straight line under various conditions. When the standard equation of a straight line is given, when the angle of inclination of the line is given, when the coordinates of 2 points on the line is given, to recognize the condition of parallel lines,